Okay, class. Now, I think by now you have written the question and you have read the question also. In the last class, we stopped at this. And I'll have to start with Len's law today. So let us just complete this topic. So this says that a coil of cross-sectional area A lies in a uniform magnetic field with its plane perpendicular to the field. In this position, normal to the coil makes an angle 0 degree with the field. The coil rotates at a uniform rate to complete one rotation in time t. Find average induced EMF in the coil during the interval when the coil rotates from 0 degree to 90 degree position, and second one 90 degree to 180 degree position. I hope everyone has written the question. Anyone who wants me to show the question again? Anyone? All have written? Because I want your attention here in this question. It's an important question. All have written or not? Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay. Okay. See, basically, you have a circle. If you learn it in the form of circle, it's better. What is the total angle we have? Let's say here this is 0 degree. Then here we have 90 degree. Here we have 180 degree. And here we have 270 degree, and here we have 360 degree back complete. Correct. So this part is there. This is there. This is what we have. Now, what does it say? It says that the coil rotates at a uniform rate to complete one rotation in time t. Okay, to complete one rotation in time t means from 0 degree joint Sidra. Okay, so pay attention in this question, class. It says one complete rotation from 0 degree. See, it says from one complete rotation. This is t. So your time period, one time period, this is complete rotation, that is 360 degree. Agreed? One rotation is the one time period. One rotation is one time period. Now you have to calculate for 0 degree to 90 degree position. Let's start from 0. And let's move to 90 degree. Till here means this quadrant. Yes. This is how much? This quadrant, this is how much of a circle? If you see. If you see here, this is how much of a circle. What is the fraction? All of you must know fraction, decimals, integers and all. So what is this? How much fraction is this? Yes, Khadija.
1/4.
Yes, Khadija?
1/4.
1/4. Very good. This is 1/4. So if total time is t and we want 1/4, so it will be t by 4. So time period for this question is t by 4. Okay, time period for this question is t by 4. Now we have to calculate the flux for both the positions. So phi 1, the first one, what is the formula for flux? B dot A, BA cos theta. So let's write down the first angle. This is BA cos 0 degree, which is equal to BA. What is the second angle given? BA cos 180, no, 90 degree.
90 degree, ma'am.
Yeah, 90 degree. BA cos 90 degree, straight away 0. So change in flux we have. What do we have to calculate? We have to calculate the induced EMF. That is our task. So this is how do we calculate the change in EMF? We have studied Faraday's laws of EMI. This says that it is minus delta phi over delta t. What is the change in the flux? What is the value of the change in the flux? Final, see already this minus sign is there. Now what is the
Final minus
final
initial.
flux? C, correct. Minus, what is the initial flux?
BA.
BA divided by time period is T by 4. So what is the formula? This 4 will go up. Final answer is 4BA divided by T. Okay. And when we come to the next part, second part, this was the first part. Second part, 90 degree to 180 degree. See. If this is the circle, again, you'll be having 0 degree here. This is 90 degree. This is 180 degree complete. This is 270 degree. And here again, 360 degree. And if I break it into four parts, four even parts are possible. If I break it into 4 parts, so it is from 90 degree to 180 degree. Means 90 degree to 180 degree, this part. So again, we can say the time period, see total time period is 360 degree. So here the time period is 2t by 4, same question. Okay. Now when we are calculating this, phi 1, so angle is 90 degree. So BA cos 90 degree is 0. Phi 2 is BA cos 180 degree is minus of BA. So when we are calculating the flux, EMI minus delta phi over delta t, so minus. What is the final one? Minus BA minus 0 by t by 4, we'll get the same answer. It's a coincidence that we are getting the same answer. Do not remember or learn it like a formula. This one, no. Solve all the steps which we have studied. Write it down. Any queries in this, please ask. Write it from you. Okay, class, now the next topic is Lenz's law. So when we were discussing the Faraday's law, that time I told you that U have E is equal to minus d phi over dt. So minus sign was left to be discussed. And at time I told you that we'll be discussing it in Lenz's law. So what exactly is Lenz's law? Lenz's law says that you have studied till now that there is an induced EMF produced and there is an induced current produced. So this magnitude part we have already covered. So we need not do that magnitude part again. But there is one more thing which we have to do, that is the direction. So direction of this induced current is given by this Lenz's law. How? See, this Lenz's law basically says that whatever is the cause that is producing the induced current, direction will be in such a manner to oppose it. Oppose that cause. Suppose, let's say, magnetic field lines are increasing, therefore magnetic flux is increasing, and this is producing an induced current. Correct? This is a case. Now I have got the magnitude of induced current. Now I want to develop what? I want to develop the direction. That's what our task is. Magnetic field is increasing. Magnetic field is increasing. The magnetic flux is also increasing. And now we have to find out this direction of induced current. So how will we determine this direction of induced current? It will be in such a manner to oppose its cause. Now, in this equation, what is the cause of the induced current? You can easily see that this is the cause of the induced current. So, induced current will align itself in such a way that the flux decreases or magnetic field decreases. If magnetic field decreases, automatically the flux will decrease. So it will try to arrange itself and make itself in a manner that the magnetic field and the flux will decrease. Just the opposite, you can reverse it. If this is decreasing, induced current will be produced, then the flux will be increased by the induced current. Induced current will in any case will try to oppose whatever is producing it, and that is what is meant by Lenz's law. So what is Lenz's law? Direction of induced current is such that it opposes the cause that produces it, that is the change in flux. So Lenz's law is in accordance with conservation of energy. This comes a lot. Lenz's law is in conservation of energy. Now let us see some practical applications portion. Look at this. There is a magnet which is coming. This magnet is coming. Okay. So what is the cause? See, magnet is coming. We have studied Faraday's laws in the Friday's class, extra class we had. So we had covered everything. Those who were absent, they need to see the video and they have missed everything because extra classes you people think are for fun. So those who were there, they have attended the class properly and the entire portion was completed in that class. And when the questions will be asked, then you'll not be answering. So we have studied in the Friday's class that whenever in Faraday's experiments, we have seen that the bar magnet, whenever it moves, magnetic field lines are produced. So what is the cause of magnetic field lines which are being produced? The cause here
Bar magnet. The bar magnet is the cause.
Yes, Yaya.
The bar magnet is the cause.
Bar magnet.
Is the cause.
Bar magnet is the cause, but what is the cause in this bar magnet? Within this?
North.
The North Pole. Okay. The approaching North Pole. North Pole, exactly. See, bar magnet has two sides and both sides will make your answer different. So that's why you have to be clear with the fact which side you are referring. So suppose the cause here is approaching North Pole. approaching North Pole is the cause. Because of the approaching North Pole, there is induced current produced. Now, what is the aim of the induced current before that? What is happening? The cause is approaching North Pole. Now, what is the aim? How will we decide the direction? There has to be some basis on which we'll decide the direction. So in that case, you will see that the aim here will be, if the North Pole is coming, that is the cause. So Lenz law says it will oppose the cause. So it will oppose this, means it will oppose the North Pole. So how can the North Pole be opposed? Which polarity do you think should be developed here, which can oppose the North Pole?
North.
North. North only, because like and like will repel each other. So what does this bar magnet do? It will develop north polarity. So that this is opposed, now it will move in opposite direction, work done successfully. And what is the direction of this induced current? See, it is anti-clock. Okay, we'll see some more cases. First, write down this. See the next example here, south polarity is coming. So the cause will be approaching south pole. Now, in order to repel south pole, south polarity will be developed in the coil like this. So the aim was to repel south pole. So if south polarity is developed, direction of induced current is clockwise. So this way you will be getting figures where you have to figure out the directions. Now see, north pole is moving away. So magnetic field lines are decreasing because magnet is moving away. So magnetic field will decrease, flux will decrease. But we are not concerned with how much the flux is decreasing or how much the flux is increasing. For us, there has to be a change, whether it is increment or decrement. Even if this flux or magnetic field line, these are decreasing, there is a change produced. So if the change is being produced, we'll be having the induced current in our calculation. So what is the cause now? Moving away of north. So can you answer which polarity will be developed?
South.
South. North is it?
Yes, sir.
See, now this is moving away. Now what is the aim? If it is moving away, now we will try to bring it back. Means now the
South.
aim is to attract North Pole. So answer is right. South polarity will be developed. Answer is clockwise because south will now attract. So this way this has been repaired. Write down these two cases too. Okay, now this is an example and a question from your textbook only. So we'll discuss this. Now see, there are two cases which are possible. Okay, just wait a second. Uh, yes, so see, there are two cases that we will see. First is, suppose this is a loop and this is entering the magnetic field. You all have to be and have to answer now because we have discussed many cases. Now let's start with you, Mariam Lohani. Mariam Lohani, you tell me when this, forget anything that is written aside. You'll not understand it. Just listen, see this magnetic field part. This part, just have an eye on this. Yes, Mariam Lohani, you tell me if this is entering, will the magnetic field increase or decrease? Yes, Mariam Lohani, will the magnetic field increase or decrease? It is entering in the magnetic field. Yes? Increase or decrease or nothing will happen, Mariam. What do you think is happening? Is increasing, the magnetic field is increasing, it's decreasing, nothing is happening. Mariam, quickly answer. It's a very easy question. If you're speaking something, your voice is not audible, you should use the chat column instead if you're answering something. And we all are waiting for your response. Yes, answer. Mariam Lohani, what will be the answer if this coil, this has just entered the magnetic field and it is going inside this, it is coming here. What do you think is happening? Number of field lines are getting more, they are increasing, or you think it is decreasing, or you think nothing, no change will occur? What do you think? Mariam, use the chat column because nothing is audible. If you are saying something. Yes, Mariam, can you use the chat column? Can you hear us? Yes. Mariam, your voice wasn't audible through the chat column, and I'm telling other students. She's saying increases. So she's right. Magnetic field will increase. Good, Mariam. It will increase. Mariam, just check your connection and your this wiring because your voice wasn't audible to me. So if it's there is an issue from my side, so somebody tell me who was able to hear her because I wasn't able to hear her. Anyone who could hear?
No, ma'am.
No. So, Mariam, just checked your connection and everything because we were not able to hear. Anyways, yes, so Mariam is right. Okay. So Mariam is right. When the loop is entering the field, lots and lots of magnetic fields will be coming within this part. So, magnetic field will increase. Sidra, Sidra, you tell me if magnetic field is increasing, what will happen to flux, magnetic flux? Will it increase, decrease, or remain the same? Sidra. decrease. What is magnetic flux, Sidra? Magnetic field is increasing, but flux will decrease. Magnetic flux's definition, Sidra, please revise and come in the next class. Magnetic flux was the first topic which we have done in EMI. Magnetic flux means number of field lines which are entering normally, means perpendicularly. So if field lines are more, maximum field lines are entering. So it is increasing the flux. So what will happen? Flux will increase. Okay. Now, flux is increasing, magnetic field is increasing, flux is increasing. Rishita, you tell me now what is the purpose of induced current? Induced current will definitely be there because there is a change. Now, what will be the purpose? What is the aim of induced current, Rishita?
It reduces the original current.
Current, to reduce the current.
No, the magnetic field.
Magnetic field or magnetic flux. Current is itself cannot reduce itself. We are talking about current only. Okay. So yes, Rishita
Yeah.
is right. The induced current will try to now decrease the flux because of the increase in the flux only induced current was produced. And according to Lenz's law, induced current tries to oppose the cause, and the cause is increasing magnetic flux. So it will oppose it. It will try to decrease it. How was flux increased? Because magnetic field line was increased. So how will the flux decrease? When the magnetic field lines are decreased. Now, these cross symbols are showing that magnetic field is pointing inside. This is the symbol for invert. So magnetic field is inwards into the page. This is the original magnetic field. Now, Yahya, you tell me the induced magnetic field should be inwards or outwards? One or two? See, we want to decrease the magnetic field. Use your vectors, apply your vectors, Yahya. See, if you will use one, will the magnetic field further increase? Or will it further decrease? Use your vectors, two vectors in same direction, two vectors in opposite direction. Yes, Yaya. Your answer, Yaya. Your answer in this, what do you think? One, it should be induced magnetic field should also be like the original magnetic field pointing inwards only, or it should be in the opposite direction.
We have to decrease the magnetic field, right, ma'am?
Yes, we have to decrease it. It is increasing, so we have to decrease it.
It should be in the same direction.
Okay, two vectors in the same direction, they are decreased according to you. A plus B parallel, two parallel vectors, sum of two parallel vectors is less. If two vectors are parallel, Yaya, do you add or subtract? You tell me.
Subtract.
Add. If two vectors are in opposite direction, 180-degree, anti-parallel, what do you do? Add or subtract?
Subtract.
Subtract. So in subtraction, where you are decreasing something, where you are subtracting something, deleting something, in that case, the entire result will be more, or where you are adding both of them.
It will be less.
See, now again tell me, if we are using in the same direction, original magnetic field is inwards, you can see these cross. And
Yes.
the other magnetic field which is developing, that is induced magnetic field. This can be inwards or it can be outwards. Okay, so if it is inwards, yeah, the net magnetic field will be added. No, both of
Yes.
these will be pointing inwards. So you will add both of them. If we drop our magnetic field in the opposite direction, then the result will be less, and then we can decrease the magnetic field. Is it clear?
Yes, ma'am.
Okay. So the direction of induced magnetic field is not this one. Direction of induced magnetic field is outwards. This is induced magnetic field. It is pointing outwards. Outwards means towards me, towards us, away from the screen, perpendicularly on the screen. Okay. Sufyan. Sufyan, you tell me, if you remember, we have done magnetics completely. Chapter 4 also you have completed. Now, Sufyan, you tell me, if the magnetic field is pointing outwards, so you put your thumb along the direction of magnetic field, curl your fingers and tell me what is the direction of induced current in your in your coil, clockwise or anti-clockwise? Thumb will be pointing towards the magnetic field, and we have chosen that our induced magnetic field will be outwards. So yes, okay, Sufyan has answered. He says clockwise. Okay, if you put your right thumb perpendicular to the screen, fingers, how come your fingers are curling clockwise, Sufyan? Just check again. You have to put your thumb perpendicularly wherever the field is produced. See, look in the camera. You have the coil. Magnetic field is now away from the screen. It is outwards. It is pointing towards me. Because if we take it inwards, it will further increase the magnetic field. So we have taken it towards ourselves. Now look, thumb in this direction, curling of fingers. Which direction is this? Anti-clockwise. So the induced current will be developed in this direction, which is anti-clockwise. Tell me, is it clear to all of you? This part is clear? Give a thumbs up, react, yes, say something.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay.
Yes, ma'am.
All right. So this was an important portion. One more thing, let's see. Now you have to be quick in this. This coil was there earlier like this. Now this is exiting. It is coming out. Khadija, will the magnetic field increase or decrease?
Decrease.
Decrease. And magnetic flux, Khadija?
Decrease.
Decrease. Very good. Because it is coming out, so magnetic field lines will decrease. Or you can say both the same things. Because of this only, the flux further decreases. Very good, Khadija. Now, if this is the case, we have to know what is the purpose of it, right? So, Taha, can you tell us what will be the aim of the induced magnetic field? Sorry, the induced current?
To oppose the changes in magnetic flux.
Yeah, so how will it oppose? If magnetic field is decreasing, so it will try to
It will increase
increase.
magnetic field.
Increase. Very good. It will now, our induced current will try to increase this. This is decreasing, so our induced current will try to increase this. Correct? So one original magnetic field is still pointing inwards. Siddiqa, you tell me, the induced magnetic field should also point inwards or it should point outwards? Siddiqa. Purpose is to decrease magnetic field.
Inwards.
Inwards, correct. Because inwards, both the vectors will be added. Original plus induced. This will increase our net answer. And therefore, it will help in changing it. Okay, correct. Now, Sufyan, you again answer. If this induced magnetic field is pointing inwards, what should be the direction of induced current in the coil? Yes, Sufyan has answered. Now you're saying anti-clockwise, Sufyan. magnetic field is going inside. Your thumb is inside. Which direction is this? Clockwise. If it was, and Sufyan, you should also think in this manner, when it was outside, so you were getting anti-clockwise. So if it is inside, it will definitely be clockwise. Answers will obviously be opposite in these cases. So how can you say anti-clockwise, Sufyan? It means you have not understood. Have you understood or not, Sufyan?
Yes.
So in this case, this will be in opposite direction. This will be clockwise. So like this, random figures will be given, and this was a very important topic, and random shapes you'll be having, random cases you'll be having. So you have to solve in this pattern. Then only you'll be able to conclude your answers. Okay. Write down this. Just don't look at this number. The context is different. Context is this one is for the first one. This was is for the second one. Increase the flux for the first one and decrease the flux the same. This theory part written is for this one. So you can change the number, make 1 and 2 according to your. It's just that this is written as 2. So don't be confused. This is the same thing which we have discussed. Write it and text me done class once completed. I think time is also up. Write and text me done. Okay then. You all can leave. Let's meet on Thursday now. Okay, Thursday we'll complete this. So, and we'll start with induction. That would be the last portion. Okay, just appear for your after class assessment.
Thank you, ma'am.
Thank you, class.
Thank you, ma'am.